Hello everybody, I am Dr. Mrutyunjay Das, HOD Electrical Department, MSc, Baripada. So today I will discuss about the control system engineering and the chapter 5, that is time response analysis. So whenever we are discussing about the time response analysis, that means we will have to discuss about the response which will vary with respect to time. So that means response means that is the output of a system. So whenever we are giving any system, means input to the system, automatically we will get some output. So the output, if the input is time variant, then automatically the output will also vary along with the time. So after deriving the mathematical model of the system, analysis of the performance is needed. That is for designing to find out the accuracy and the speed of the control systems. So the responses of various types of inputs are analyzed to study the specifications. Specifications means again we are coming into the accuracy, stability, settling time and the overshoot of the oscillations. So therefore the time response can also be defined as how a system behaves in accordance with time when a specified test signal is being applied. So generally the time response is two parts, because whenever we are giving the input to the system, the automatically output will come, but the output, whenever we are getting the output, that will come from the initial state to the final state, and that will not come within a very short period of time, that will take some time. So within that time, the time means the initial whatever the input is given, the initial state will come to the final state, and after the final state has been reached, it will continue with its final state. So therefore the period within which, or the output which will vary from initial to the final state, that is known as the transient response. So the period for which the state will change from its initial to final, that is also known as the transient period. So therefore we can say whether it is a transient response or the transient response will occur in the transient periods. Similarly, after the transient response has been over, that means whenever the initial state has been changed to final state, then the state will continue in the same state. That's why we are calling it as a final state, or we are calling it as a steady state, because that response will continue with the same output, means it will not change with respect to time further. So therefore that period is known as the steady state period, and that response is known as the steady state response. So therefore we can give this diagram. So whenever the output we are getting, first it will oscillate along with the time, means whenever it will oscillate, it will go above our desired output and also it will come below our desired output. So therefore we are calling it as an oscillation, and that will, the oscillation mainly, it will continue up to its transient period. After the transient period, whatever we are giving here, the transient period is over, then automatically the output remains constant. That is known as the steady state period, and within that steady state period the responses will remain constant or steady. So therefore the response will have the two parts. One is known as the transient response, another is known as the steady state response. So now we will discuss about the one by one. We will discuss, first we will discuss about the transient response, then we will discuss about the steady state response. Okay, next we will go to the transient response and steady state response one by one. Okay, so now whenever we are discussing about the transient response, it has two parts. One is the transient part, another is the steady state part. The combination of these two parts is known as the time response, total time response we can say. So therefore the response means the output as a function of time. So the total time response, that we are calling it as a CT. Generally we are taking RT as the input and CT as the output. So therefore the total time response CT of a control system, that consists of transient response, also sometimes it is known as the dynamic response, because it changes along with the time, and that is given as the CTRT, TR for transient, and steady state response, that is CSST, SS for steady state. So therefore we can see the equation as CT is equal to CTRT plus CSST. So where CT is given as the total time response, and CTRT is known as the transient response, and CSST is known as the steady state response. So therefore we will discuss now as the transient response now. So after applying the input to the control system, the output takes certain time to reach the steady state. So the output will be in the transient state, means it is in the variable state till it goes to a steady state, means the final state. So therefore, the response of the control system during the transient state is known as the transient response, and the period is known as the transient period. So therefore, the transient response will be 0, means see, the transient response means it is the oscillation, and the magnitude of oscillation will goes on decreasing. That's why we are saying it is a damped oscillation. So whenever it is going to be damped, that means as long as the time increases, the damping also increases, means the oscillation goes on decreasing. So therefore, the magnitude of oscillation on both sides is positive and negative, that will go on decreasing. So therefore, we can say whenever the time is 0, we have a large, means the oscillations is large. Whenever the time t approaches infinity, the oscillations goes on decreasing, or we can say the oscillation dies out. So ideally, this value of t at infinity is 0, or whenever we are saying infinity is not exactly infinity, it is 5 times as the time constant. Sometimes we are taking it as a 3 times time constant, or sometimes we are taking it as a 5 times time constant. Because whenever we are taking it as a steady state means we are desired output or the constant part, whatever we are saying. So whenever the transient part reaches its 98% or 102%, that we are saying it is a 2% of the desired output, plus minus 2%. So in that case, we can say the response reaches its steady state response. So that's why mathematically we can write this, that limit CTRT when t approaches to 0, that gives you, means t approaches to infinity, that gives you 0. So then we come the steady state response, because once the transient part is over, then the response enters into the steady state part. So therefore, the part of the time response that remains even after the transient response has 0 value for larger values of t is known as the steady state response. This means that the transient response will be 0 even during the steady state. So therefore, this is the graph. Here we are showing the transient state part and is the steady state part. So when t is increasing, first the transient part will be covered. Then after the transient part, whenever the responses reaches near about the steady state part, that is plus minus 2% of the steady state, then we are saying it is a steady state response, and the steady state time or the steady state period comes, okay, and it will continue up to the infinity time. So then we will see whenever we are giving some input to get some output, because whenever the control system is being designed, after the mathematical modeling, the control system is being designed. So whenever the control system is being designed, it will have to be tested for its better performance. So for the better performance, we will have to give some kind of inputs. So some kind of inputs means the signals may be a sudden, maybe that means we can say that is a shock wave. That is called a sudden input, or that is gradually increasing, or that is a constant input, or that is some parabolic mode. So therefore, there are all the inputs can be classified into these 4 categories. So therefore, one by one we will see how the responses will come due to the individual different types of inputs. So generally we are using the standard test signals as unit impulse signal, unit step signal, unit ramp signal, and unit parabolic signal. So one by one we will study how the responses will come due to these inputs whenever the inputs is being given one by one. Okay. So we will see the next, whenever the standard test signals are being used, how the time responses come. Okay. So now we will see how the responses will come in a control system whenever the different types of signals will be given as an input. So first we will see the unit impulse signal. So whenever you are saying unit impulse signal means its magnitude is 1 always, and it is denoted as delta t. So the delta t will be equals to 0. This is the graph for this, means except for t is equal to 0, for every other time its value is 0. Only at t is equal to 0 it will have some value. So therefore we can take it as a sudden signal or sudden shock wave signals. So the following figure, this figure shows the impulse signal. Then we will come to the unit step signal. So unit step signal means the signal will be given at a particular time when t is equal to 0 and its magnitude is 1, therefore we are saying it as an input signal. So its magnitude will remain constant for t is equal to up to t is equal to infinity. So therefore we are saying it as a unit step signal. So we can say mathematically the ut is equal to 1 for t is greater than equal to 1, because we are saying here, because we are looking here, for t is greater than equal to 0, the value is 1. For t is less than 0, we are getting t is equal to, ut is equal to 0. So this is the graph for the figure for the unit step signals. Then we can see the unit ramp signal. So unit ramp signal, it is given as defined as RT, and RT is equal to t for t is greater than equal to 0, and it will be equals to 0 for t is less than 0. So these are the continuous waves actually. So therefore, after t is greater than equal to 0, t increases linearly. Okay, so therefore we can say the signal will increase gradually. So we'll have to see how the responses will be there for a gradual increasing signals. So we can write the unit ramp signal RT in terms of the unit step signal UT as RT is equal to t into UT. Just like whenever we are saying the graph of x and y, we are saying it as x is equal to a into y, like that. So similarly, RT is equal to t into UT. That means this is a unit step function which will vary along with the time. Then we can say unit parabolic signal. So a unit parabolic signal PT is defined as PT is equal to t square by 2, because it is a parabolic wave. So its value will be t square by 2 when t is greater than equal to 0, and its value will be 0 when t is less than 0. So therefore this is also a continuous signal. So you can write the parabolic signal in this form. So PT is equal to, this can also be written in the form of unit step signal. So that can be written as PT is equal to t square by 2 into UT. So then we will see the responses of the first order system. So that means whenever we are saying it is a first order means the denominator term s will come there. So this includes the Laplace transformation actually. So in the denominator, the power of s should be equals to 1, and that will be equals to 1 if there will be only one pole in the system. So that means in the forward path gain. So this shows Rs is the Laplace transformation of RT, Cs is the Laplace transformation of CT. So this figure shows the 1 by St is given as the forward gain, and we are taking a unit feedback path. So unit feedback path means Hs is equal to 1 here. So normally transfer function is given by Cs by Rs, and that is equal to Gs by 1 plus Gs. Because Hs is equal to 1, so therefore we are writing it as Gs by 1 plus Gs instead of Gs by 1 plus Gs Hs. So now what we will have to do here, we will have to substitute 1 by St instead of Gs. So if we will substitute this in the above expression, Cs by Rs will be equals to 1 by St divided by 1 by St divided by 1 plus 1 by St. So if we will simplify it, we will get 1 by St plus 1. So in that case, Cs will be equals to 1 by St plus 1 into Rs. So now what will happen? Rs is the input signal, that is the Laplace transformation of the input signal. Now what we will have to see, if we will give the input, any one type of input what is being described as a standard test signals, whether it will be a unit step signal, whether it will be a unit ramp signal, or whether it will be a unit parabolic signal, so whatever it may be. So one by one we will give the input signal, and that will be equals to RT. So now we will have to take the Laplace transformation of the input signals, that will become Rs. So now if we will substitute the value of Rs here, then if we will simplify it, we will get the value of the Cs, that is the output response. So now once we will get the Cs, then again by using the inverse Laplace transformation, we can be able to get the CT, that is the time response of the output. So therefore that is known as the time response analysis. Okay, so today we have discussed about what is the meaning of the time response, and why the time response analysis is required, and for the time response analysis what are the different standard test signals will have to be used, and by using the standard test signals, in the next we will have to see what will be the responses. Then we will have to analyze the responses, and we will see how it behaves to different inputs. So thank you.